All right, good morning, guys. Today we're going to look at standard 3.11, which deals with conic sections. Conic sections are circles, ellipses, hyperbolas, parabolas, just different kinds of curves that we get by squaring sometimes x and y, sometimes just one or the other. So I'm going to go over how we can use some shortcuts to figure out which graph best fits without actually knowing all the different parts to the equation. So what I like to do is look at a specific point that's unique to each graph. So if we grab a point that is unique to each graph, so let's look at this top point right here. So for choice A, it looks like it's -1.5 and 6.5. Wow. This is very horrible writing, but you get the idea. So -1.5 and 6.5. For choice B, I would say this bottom point looks unique to its graph. None of the other choices have it. So that's +1.5, +1.5, and 6.5. Sorry, -6.5. And then we go choice C. Choice C, this far right point looks unique, so that's over 6.5. And down 1.5. And then choice D, this far left point, which looks like -6.5 and up 1.5. All right, so as you can see, we've just picked a point that shows up on each of the graphs, only one graph at a time. So -1 and 6.5 didn't show up on any of the other graphs. Okay, so we're just kind of picking a point unique to each one. Now what I'm going to do is I'm going to key each of these points into my equation, and whichever one gives me 16, or the closest to 16, will be the correct one. Because remember, these points may not be exact. This may be over 6.4, so I'm just approximating it. So we're going to go and grab the calculator here. There it is. And we're going to key these points in. All right, so 6.5. So I have parentheses x, which was -1.5, minus 5 halves. You can change that to 2.5 if you want to, squared, plus y, which was 6.5, plus 3 halves. If I can grab my 3 over 2 squared, and that should equal 16. It didn't equal 16, so that means choice A is obviously wrong. All right, just double checking, make sure we keyed it in correctly. Okay. Oh, that's why we're way off. Make sure you get it typed in correctly. I should have had a plus sign. New calculator, getting used to it. Okay, so we get 80. So choice A ended up equaling 80. All right, so we can see that's not 16. That's no good. All right, now we're going to go in and try choice B. I can hit second enter, guys, if you'll remember, and that'll bring up the last thing I entered in. So I just need to go make a couple of changes. My x needed to be +1.5. So I go back and delete the negative. And my y needed to be -6.5. So second, insert. Now that the 6 is blinking, I can put a negative right in front of it and hit enter. And B gives me 26. So that was a lot closer. So we'll say equals 26, but still that's pretty far off. If we go with choice C, so second enter, try choice C out, which was +6.5. So second enter brings back up my equation. change it to positive 6.5 and delete, and then I want positive 1.5. Okay. That one gave me sorry guys, should have been negative 1.5 for C because we went down 1.5. Okay, so the negative was right. We need it to be negative 1.5. Okay. And we get 16. So C ends up giving us right on 16. So the point we picked from C gives us 16. And we'll just check D just to make sure there's not a trick somewhere in here. Should be negative 6.5. So second, insert negative, and positive 1.5. Okay. Gives me 90. So I can see that obviously it's not D. 16 is what I needed it to equal once I plugged in an x and y for the equation. 16 is what I got C to equal, so that means C is the correct answer. Now notice how B and C were both the closest to getting 16. Well, B and C were also the pictures closest to the answer. D and A were further away from the actual correct graph, and their values once we plugged in were further away. So that just shows you that these numbers don't have to be exact, the points that I pick. What I'm really trying to get is the number closest to it. Because as I was saying before, if this was 6.4, it's obviously not going to give me the exact value that it equals, but I can get the one that puts me closest to what it equals, so I'm getting the points that are closest to actually making up that curve. So that's how we take it when they give us the equation and we're matching it up with the graph. Now let's look at if they give me some points and I need to get an equation from it. It's the same idea. I've got points on my graph, and I'm just going to plug them in until the equation works out. Now if I, again, grab my calculator, there it is, and I go and plug in my points, it says foci, it says vertices. Never, ever, ever mess with foci. Foci are inside the curve. They're never touching the curve. Think of vertex like a parabola. It's the bottom point on the curve or the top point on the curve. So vertices are actually on the curve. They're the end points, high points, low points, just like they are on the parabola. Same thing for all other conic sections. So vertices, it gives you two of them, 0, 2, and 0, negative 2. Pick one. It doesn't make a difference. If we get a lot of things that keep coming out again and again, we'll try the second one. But usually one of them is enough, gives you enough information. So let's go with 0, positive 2. It's less stuff to type in. So I go 0, positive 2. Take my equation for A. So it says y squared. So there's my x. There's my y. So that's 2 squared. These fractions have exponents, so I'm just going to put them in parentheses just to make sure everything gets grouped correctly. So y squared over 4 plus x. X was 0. So 0 squared over 5. And should equal, that one comes out and equals 1. So choice A we can see works. Don't jump right on choice A. Always be suspicious of the first choice. Let's go try out B. Second, enter. Okay, so all they did was switch the x and y. So now it's x squared over 4. So it's 0 squared over 4. And now it's minus, I've got the minus here in the middle, y squared, which is 2 squared. All right, so when we tried it here, we got, so this one equaled 1. That was a check. This one equaled negative, let me get my eraser. Okay. Okay. This one equaled negative 0.8, so no good. For C, let's check it out. Second enter brings back my equation. y squared, so that was 2 squared over 4, minus x squared, 0 squared over 5. That one also gives me 1. So I've got 2 of them that equaled 1 like they're supposed to. So that's good that we went and checked the other ones and didn't just jump on the first one, because it could be choice C. And let's check choice D, see if it works also. Y squared, that's 2 squared. Remember, y was from right here. Over the square root of 5. So square root, second square root, and then I need to insert a 5. Close my square root, close my fraction. Make sure you get enough parentheses in there. Over x squared, which was 0. So 0 squared over 2. Right. And this one obviously is not right. It's 1.8 roughly. So that one's no good. So we got 2 of them that equaled 1. Well, we've got to pay attention when they give us this point type problem. We have got to read the question. It said hyperbola. So what's the difference in these 2 equations? One has a plus sign, one has a minus sign. If I will read the question, this hyperbola tells me which one to go to. I don't have to memorize which one uses a plus, which one uses a minus, because I have my reference page. Reference page tells me, this is the reference page they give you at the beginning of the test. Reference page tells me at the top of the second page the equation for ellipse and the equation for hyperbola. Well, what's the difference in the two? Ellipse has a plus sign in the middle. Hyperbola has a minus sign in the middle. So we needed a hyperbola, so we need the one with the minus sign. So if we go back here, we needed the minus sign. We needed the minus sign because we were dealing with hyperbola. So that means A is no longer any good, and choice C is our correct answer. All right, now that's just a couple of techniques to do conic sections. When they talk about parabola, hyperbola, ellipse, they give you this type of graph. They give you this type of graph. They give you this type of graph. They give you a circle. Those are just different types of conic sections. They give you those type of graphs. We know that we can use the reference page to help us dig into which equations based on which word they use. So that can narrow a few choices. And we can also just use the idea of take a point on the curve, plug it in, and when it's equal, you have the equation for all of those points. All right, talk to you later. See you in class, guys.